Okay, so I'm going to work out the using trig ratios worksheet so you can see how these problems should be done. All right, so for each problem, draw a picture, set up the ratio, and solve. Side lengths should be to the nearest tenth, angles to the nearest degree, and then remember correct units. Okay, so Lenny is planning to cut down a pine tree. He wants to make sure that the tree will not hit his truck when it falls. The tree has a shadow that's 150 feet long, and an angle of elevation from the base of the shadow to the top of the tree is 50 degrees. Okay, so this is what I'm seeing here, is I'm seeing that we have a tree, and the shadow of the tree, so here's the shadow of the tree is 150 feet. All right, the angle of elevation, which means from the ground to the hypotenuse, so from the shadow to the top of the tree, so we have this right here, which is, I'm just going to do dotted line, but so this is 50 degrees. So the question is, how tall is the tree? So what we are looking for is this right here, which is the height. So if we have opposite and adjacent, that looks like tangent. So the tangent of 50 degrees, opposite would be h over adjacent would be 150. So I need to multiply these two together. So I need to do 150 tangent of 50 degrees, and I'm getting 178.8. 178.8. So 178.8 feet. So that is the height of the tree. All right. Okay, next up, a kite is flown with 240 yards of string. The angle of elevation is 55 degrees. So how high above the ground is the kite? Okay, so here's our little kite, which will make the little kite look like a kite. There we go. Okay, so we're flying a kite. Somebody is down here flying a kite. They have 240 yards of string. So the string goes like this. So that's 240 yards of string. The angle of elevation with the string is 55 degrees. So if we want to think of this right here, so this is 55 degrees, and we're trying to figure out the height of the kite. So how high above the ground is the kite? All right, so this looks like sine. So the sine of 55 degrees is opposite over hypotenuse. So to solve, we just need to multiply 240 and then sine of 55. So clear this off. So 240 sine of 55 degrees, and I'm getting 196.6. So 196.6 yards. Alrighty. Okay, next up, you planted a new tree in your yard. The support wire needs to be at an 82-degree angle with the tree to fully support it. So if the wire is placed 3.8 feet up the new tree, how much wire do you need? Okay, so we got another tree here. So here's our tree. You know, when they plant trees, they put wire down to secure in the ground. So it looks to me like our right triangle is going to be right there. Okay, so the support wire needs to be at an 82-degree angle with the tree. So the wire to the tree needs to be 82 degrees, which is that one right there. The wire is 3.8 feet up the tree, so this right here is 3.8 feet. So how much wire do you need? So we need that, because this is the wire. The angle between the wire and the tree is 82 degrees. and the wire is 3.8 feet up the height of the tree, and we want to figure out how much wire we need. All right, so this looks like cosine to me. So cosine of 82 degrees is adjacent, which is 3.8, over hypotenuse, which is x. So to solve this, I need to switch those two. So we need to do 3.8 divided by cosine of 82 degrees, and I'm getting 27.3. So this needs to be 27.3 feet. And there we go for number 3. All right, number 4, the angle of depression from the top of a flagpole to a point on the ground is 35 degrees. The point on the ground is 82 feet from the base of the flagpole. So how tall is the flagpole? All right, so first up, we have a flagpole. So here's our flagpole here. So we'll, make it look a little, okay. All right, so the angle of depression is going to be from the top. So we would need to think of this up here, right there. So the angle of depression is going to be right here. So it's 35 degrees. So when I draw this down here, this angle of depression is 35 degrees. All right, the point on the ground is 82 feet from the base of the flagpole. So where this meets, so this right here, so this distance right here is 82 feet. So this is 82 feet. Now, there's two ways we can do this, because if we look at this triangle right here, then this isn't 35. It over here would be 55, because we know that's going to be 90 degrees. Or we know that the angle of depression and the angle of elevation are congruent. So if this is 35 degrees, this one right here will also be 35 degrees. Or we could, because what we want to know is the height of the flagpole. Or we could make our triangle out here, which would also be a right triangle. So this is what we're looking for, the height, and then the 82 is up here. So however we want to think of this, it looks like we're using tangent, because we know the legs of the right triangle. So the tangent of 35 degrees is, all right, so the opposite side is what we're looking for. The adjacent side is 82 feet. All right, so to get the answer, we just need to multiply those two together. So 82 times tangent, so 82 tangent 35. Am I doing the right numbers? Yep. And, whoops, sorry, I got 57.4. So 57.4 feet is the height of the flagpole. All right, next up. Okay, the sign button on your calculator is not working. So explain, in other words, another way to find the missing side, and then find the missing side without using sign. Okay, so if I could use this, I would do the sine of 46 degrees is 12 over y. The problem is I can't use sine. So what I can do, however, is if this angle right here is 46 degrees, if I subtract that, if I subtract 46 degrees from 90 degrees, that will tell me what this angle is over here. So just some simple math, we need it to be 80 and then 100. So I know that this angle is 44 degrees. Well, so now from this angle, I can do the cosine. All right, so I can use cosine from the other angle. So the cosine of 44 degrees is going to be adjacent over hypotenuse. So that means to solve this, I need to switch these two. So the missing side is going to be 12 divided by the cosine of 44. So let me clear this out of the way. So the cosine, 12 divided by the cosine of 44 degrees will give us 16.7. So 16.7, we don't have a unit. So that's it, 16.7. So that's our hypotenuse. Alrighty. Oops. All right, on to page 2. So, whoops, sorry. I'm going to make you dizzy. Okay, a rocket is launched at an angle into outer space. After a minute, the rocket has traveled 6 miles but has an altitude of 4.5. So what's the angle of elevation? Okay, so here we are. We have our rocket ship. I don't know how to make a rocket ship. Oh my gosh, this is terrible. Whatever. Okay, so the rocket ship is blasting off, right? So after a minute, the rocket, so let's just pretend. So I'm going to draw this out here. So the rocket, the rocket has traveled 6 miles, but it has an altitude of 4.5 miles. All right, so the rocket has actually gone 6 miles, which means its altitude is 4.5 miles. So here's our ground here. This is supposed to be our right angle. All right, so the question is, what is the angle of elevation? So what we're looking for is the angle measurement. So the angle of elevation that the rocket is going into the air. All right, so this looks like sine. So the sine of x degrees is, the opposite is 4.5. The hypotenuse is 6. All right, so this time I'm looking for the angle. So remember, when we need the angle, we need to do the inverse. So the inverse of 4.5 divided by 6 gives us 49-degree angle. So x is 49 degrees. Alrighty. Number 7, construction worker leans his ladder against a building, making a 60-degree angle with the ground. The ladder is 20 feet long, so how far away is the base of the ladder from the building? Okay, so here's our building right here. All right, so building. We have a ladder leaning against a building. All right, now the ladder is a 20-foot ladder. It is making a 60-degree angle with the ground. So the ladder with the ground, so down here, is a 60-degree angle. And we are trying to figure out how far away is the ladder from the building. So we're trying to figure out that. So we have a 20-foot ladder leaning against a building. The ladder and the ground is a 60-degree angle. And we're trying to figure out how far away the ladder is from the building. All right, so this looks like a cosine to me. So cosine of 60 degrees is the adjacent side, which we don't know, over the hypotenuse, which is 20. So to get this answer, we need to do 20 cosine of 60 degrees, and we get 10. We get 10. And this should be feet. So 10 feet. So we didn't even have to do any rounding on that. That was an integer answer there. Okay, a woman wants to use a 10-foot ladder to get to a window that's 8 feet above the ground. So what angle, this is not focused, goodness. So what angle does the ladder need to be? Okay, so almost same idea. So we'll make this look more like a house. All right, so we have a 10-foot ladder. So this ladder is 10 feet. So a 10-foot ladder is reaching an 8-foot window, which means that this measurement right here is 8 feet. So the question is, at what angle, so right here, what angle should this ladder be? So this is our x. So this time we're looking for an angle. Looks like sine. So the sine of x degrees. So the opposite side is 8. The hypotenuse is 10. Since we're looking for the angle, we need to do the inverse sine. So inverse sine of 8 over 10 looks like 53 degrees. So the angle is 53 degrees. All right. Okay, to estimate the width of a river, Jamie stood directly opposite a large tree on the other side of the river. He then walked 90 feet along the bank and approximated the measure of the angle between his line of sight to the tree and the river's edge to be 53 degrees. So how wide is the river? All right, so we need a good drawing on this one. All right, so we have a river. Okay. All right, so this is our river, in case you weren't sure. Okay, so Jamie, here's Jamie, is directly opposite a tree. So here's a tree, okay? So he is directly opposite a tree. Then he walked 90 feet. So he walked this way, 90 feet. Okay, so now he's down here. Okay, so he walked 90 feet. Oh, his head fell off, but that's okay. He walked 90 feet along the bank and approximated the measure between his line of sight and the tree. So see, now he's looking at the tree right here. All right, so this is where our right triangle is, okay? So he's estimating, he's trying to figure out how wide the river is. So we don't know how wide the river is, but we know he walked 90 feet this way. So this measurement right here is 90 feet. And, hold on, I lost my pace. Approximated the measure of the angle between his line of sight to the tree and the river's edge. So the angle right here between his line of sight to the tree and the river's edge. This is the river's edge right here. So this angle right here is 53 degrees. Okay, so how wide is the river? So from this angle, I'm thinking it's tangent, because obviously we don't know this measurement. If we knew this measurement, we could take this one easier than that one. All right, so tangent of 53 degrees is the opposite side, which we don't know, to the adjacent, which is 90. So to get this answer, we just need to multiply those two together. So we need 90 times the tangent of 53 degrees, and we're getting 119.4. So the river is 119.4 feet across. Okay, so this is where you really have to have good reading comprehension. Okay, because he is directly across from a tree. Okay, then he walked 90 feet along the bank of the river. So he's not walking this way. He's not walking away from the river. He's walking 90 feet along the side of the river. Then he estimated, you know, there's apps that you can do this with, by the way, that you can get on your phone. If we were in school, we would be doing that. But so then he measured that the line of sight to the tree, which is the hypotenuse, and the river's edge. So we have the line of sight and the river's edge is a 53 degree angle. So we know that this is the angle he was talking about that was 53 degrees. Okay, an ant is looking up at you with an angle of elevation of 64 degrees. You're 5 feet tall, so how far is the ant from your foot? Okay, so here you are. and you are 5 feet tall, okay? And there is a little ant on the ground. That's the ant. Just pretend. I don't know. How many legs does an ant have? I don't even know. Whatever. Okay, that's an ant. Okay, so the ant is looking up at you. So this is the ant's line of sight. And you're both on the ground here. The angle of elevation, so this right here is 64 degrees. You're 5 feet tall. So the question is, how far is the ant from your foot? So this looks like tangent to me. So the tangent of 64 degrees is the opposite over the adjacent. So to get this answer, we need to switch these two. So I need to do 5. So 5 divided by the tangent of 64. And it looks like 2.4 feet away. So the ant is 2.4 feet from your foot. So 2.4 feet. There you go. All right, so what you're going to notice in these questions, the only thing that makes it difficult is setting it up. I would definitely recommend sketching something. And I mean, you can see I'm not an amazing artist at all. But you do need to make a sketch. And somewhere in there is a right triangle. And you're going to be given 2 side measurements and an angle, or an angle and 1 side measurement, or 2 side measurements, not an angle, but you're going to be able to use a trig function, and you only know sine, cosine, and tangent to figure those out, so it's going to have to be one of those. Okay, I hope that helps.